All right, let's go talk about the timing of the mitotic cycle real quick. Let me go see, where's my mouse? There's my mouse. Let me go find a pen option. Alrighty. So what you're doing here is you're going to try to figure out, this is a cross section of an onion root tip, and it's a point in time, right? And because it's a point in time, all of these things are like arrested at the same time, and then you can create an estimate of how much time they spend in each cycle, in each phase in the cycle, to try to figure based on how many cells are in each cycle at any given time. And what I need you to do is you're scoring 100 of these, right? It says here, score 100 of these. And we're scoring 100 of these just literally for ease of calculation. So if you're having trouble figuring out which phase looks what way, go look at the virtual onion root tip activity, because it shows you like the different phases and pictures of them. Now, if you're not clear about which one it is, just skip that cell. If you don't see it, just skip that cell. It doesn't really matter. All right, so let's start out. So we've got this one up. So we're going to basically just count down, right? And count down 100 of them. So in this first one, that's an interphase. Mark. Interphase. Mark. Interphase. Mark. This one is still an interface, but I don't want to go through like all the interfaces of the world at this point. This one here, it looks pretty separated. That's an anaphase. Then this one here is also an anaphase. And let's go look at a couple of other phases. Like this one, we could still call this an anaphase, or we could decide that this is a telophase. Just march that one. This is an interphase. Let's see if we have this one is a metaphase right here. This one is again an anaphase. There's like a whole bunch of 1, 2, 3, a whole bunch of interphases. And like that, you're just going through all of them, right? And you just come up with numbers, whatever the numbers are. And then we're going to 100 because you want to have 100 nuclei counted, because you're going to turn these into percentages. And when you turn them into percentages, you take whatever number is here. Like if the number here is 72, then that's 72%. That's just for ease of calculation, right? And then to figure out how much time they spend in each of the, you're going to take the fraction. So 72 turns into 0.72 times 16, because that's the length of the complete cell cycle. And then you're going to come up with whatever that number is. And that number then represents the amount of time that each of these cells spends in that cycle out of 16 hours. Does that help? If it doesn't, please follow up.